done. You don't care how they look, but yeah, it works overall. The only thing that I still noticed is that I have like very inconsistent first layers. That's a problem I had before, so I'm not sure if like our mistreatment of the wheel touch we did caused that, but yeah, it's kind of like an ongoing issue with the printer. So I actually ordered one of those Omron Pro, and at some point we will install it. I have the parts printed, I have the probe here, so maybe do it next week, let's see. And then I would call the printer done for now. So yeah, hi there, Mike Viking. Yeah, so today we work on this one. Basically what I want to do is we're having the issue again that my camera isn't quite high enough for this machine. I still haven't figured it out. But yeah, basically what we will do is we will just rebuild the top part. We will swap out some parts. So the motor mounts here in the back will be replaced. This one is part. So basically the bottom part here will be replaced with this one. So it looks quite similar. The main difference is now it's two separate parts, so I kind of split that and it just like clicks into place. And then the big difference is this little nose here that I added. So this is new, and what this will do is later on, this will hold the top idler of the vertical belt, like the Z belt basically. So we will have two belts left and right, and then also on the front we will swap out these parts here, which are the bottom ones here. So this part will also be swapped out, and you see like the old one had two holes and the new one has a new center hole here in the middle. Same deal, this will hold a belt, or like the top idler for the belt for Z. So we will have 4 belts in Z. And then basically we have 2 motors for Z, so left and right, and each motor drives 2 belts. So it will be quite a fun construction. That's for the future. Like I already have it modeled. I think I also have it open. So this is kind of like the current state of affairs. I really haven't had a lot of time recently to work on this. But yeah, you see like the top part is kind of what we have. You know, see... Ooh. You see here the new part with the top idler for the belt, and then also on the back you see this basically new part with this nose and then the top idler for the belt. Yeah, then here basically I already modeled the front skirt. I'm not quite sure if this is the final design, but it kind of was the idea. And the white parts are LED strips, but I forgot the name now, but like the LED strips that have like no visible LEDs, like this here actually. So it's just like continuous LED basically. And that's the idea, to just have it in the front. Looks cool. Not RGB unfortunately, but I really like the pure white look of that. So that's kind of like the idea for the front. Then under the deck panel, that's where it gets kind of interesting. So the idea is basically to have the main board on the back. We still have to build something around that, and then the Raspberry and the power supply on the bottom. But the interesting part is basically this construction here with the motors. I copied this from the... I forgot the name. Printer... Let me check. I copied this, like not copy, but like I got inspiration from the RC150. Uses a similar system. So basically how it works is you have the stepper motor here on the back that is geared with this big 50-tooth gear here. This 50-tooth gear comes from the M4 extruder. So I kind of like moved it over and modified it a bit. Now basically you see you have 2 pulleys here. One pulley goes straight vertically up, so basically this goes directly, you see it here is aligned with this top idler here. So one belt will just go vertically up, and the other belt will first go to this on the bottom, and then will be looped up to here. So they're like, you see it down here, there are like 2 of those wheels. So it's quite a complex routing of the belt for that. But basically what this allows us is to have 4 belts in each corner of the bed with 2 motors. So we should have a very stable bed that can support quite a lot of weight, and everything should run smoothly. The bed, basically, I still have to like design the bed mount, but it will just run with 2 linear bearings on the 2 front rods here. So there are only 2 bearings just to like secure it in place on X, Y. And the rest is then basically the weight is held by the belts. So that's the entire idea. So yeah, that's kind of like what we are going to do. I will actually start printing those bottom parts for the corner pieces, not the skirt, just like the corner pieces next week. And then hopefully, I need to see how quickly I can print all of those because I'm not at home that much at the moment. Once we have them, we can build the bottom part. But for today, let's just rebuild the top. And I also want to make it run. So I have a main board somewhere here. So I kind of want to connect the motors and just like really make it work and just like test out everything that's running smooth. Because at the moment, I think there's like a certain weird friction in the system. Like, not friction, it's the wrong word. It's just like sometimes it's smoother, sometimes it's a bit harder. And I have a suspicion it has to do with this like super shitty belt we used in the beginning. So part of this rebuild we're gonna do now is also just using like standard Gates belts. So we just get rid of those like cheap plastic belts. I have really a suspicion that this is a lot of the problem. Cool. Yeah, lots of talking. I would say let's just kind of like start by undoing what we have so far. I'm actually, yeah, we need the vertical rods, of course. So technically, like, we will put it back into shape. And the bottom, we just make a bit more sturdy with those like temporary things we have here on the bottom. And yeah, let's just get going. I don't really have a good plan on how to do this. I think good first step would be just to like, actually let's work from upside down. Let's just get the vertical out. Actually get this off first. Very weird test contraption here. Well, okay. Silence my watch. Hi Steve, you charged the cam battery. Yes, I charged the cam battery. I also made sure it is plugged in and is charging. And I ordered also, the dummy battery. So basically it's already in Netherlands, it's just not delivered yet. So as soon as next week, we will not have any battery problems anymore, ever. Hopefully. Fingers crossed. Let's see. So I wonder how to do that best with the least amount of effort. Because technically we need to remove the belts. So I wonder whether we can just keep the assemblies kind of together. So basically we remove the belts and then no new earbuds. That's true. So still some battery issues to come. I should just remember to like after like, I don't know, like one hour, just switch the side, and then I think we should be good. And then switch it every hour. Okay, let's just remove the belts first. And then let's just do the corners individually. So I'll completely pull out the belts because we will replace them. Yeah, it's just like such shitty quality. I don't know. It's so basically for the people who like follow the project for a while. Initially, my plan was to build the printer for like super cheap price, which I gave up on because it's just like hard enough to build a printer that works. So I think I shouldn't make it even harder for me. And immediately try to build a cheap printer, which is more difficult than just building any printer. So that's basically why we use those like crappy belts. Okay, now that I have this out, I realized I forgot to get my soldering iron. So let me quickly grab that so we can put the heatsink inserts in the new parts. 1 second. So also a thing, maybe like at some point we will have a stream where like I think of everything I need in advance and I don't have to like grab stuff midstream. Okay, oops, let's also not make this mistake again. Like, let's not heat the soldering iron to like 400 degrees and then try to like use it for heatsink inserts. Okay, so basically we just have to replace this bottom part here. I'm just checking what like. So the mechanical issues we have with the movement, I'm pretty sure it's just the belt. I'm very curious to see now if we use good belts, if it changes. Oh, this also is secured by its front screws. And then we can just leave this intact. So this basically is just this roller bearing here with the screw inside. And to check, this is this part. I like this new heatsink insert tool much more than the one I had before. The one before was like very like skinny narrow, and you couldn't really like use it as a lever in this way. And I also feel like it's easier to set them like straight with this one. Actually also check what the print is doing. Print is looking good. And then we need also some new inserts. Actually really excited to see it move. I mean, we had it moving before, but like with like really weird motors and like wasn't nice. So I really hope that like now with the new belts, we get better motion. So let's see. And 2 short screws from the front. Okay, that's one side. Not throw it away. This part, by the way, I tried to print with scarf joints, which is like this new feature in Orca Slicer, but I really don't like the result. You see basically here the scarf seams. Sorry, not joints, scarf seams. So the seam is basically like pulled over this like entire distance, but I really don't think it looks good. Like it's just like it makes it way more visible. I think it's just like maybe I have to tune the values a lot more, but yeah. I pretty quickly gave up. This part goes to trash. Okay, that one was a little bit resistive. And one fresh one. Okay. So far, so good. Oh. Oh, I put a screw in. I still wonder whether I use too many screws. I think I really overdo it with the clamping of parts. But it is kind of the structural parts of the printer. So yes, it should be nice and tight. Let's actually just put them on. Oh, maybe that would be easier. Okay. So let's tighten left and right, but we don't tighten the front part yet. It's really important that like everything kind of like finds, like we need to like work on this later anyways a bit more. Today I'm not handy with tools. But basically it's important that the X gantry or X-axis basically defines the width. So basically the parts are always designed to have like a couple millimeters of play. So they can compensate for the beams being too short or too long, like those rods here. Then basically like you need to use the X-axis to like find the proper width that is like moving. So basically when you tighten this, you always hold it against the end, and then you tighten. Technically one side we can always tighten, right? Hi, Kublik. I'm fine, thank you. I had an amazing day because I was off work. So I was very not relaxed day. I was still busy, but not going to the office is always a nice day, I think. Let's remove this temporary thing here. Like I use those temporary like clamps at some point to like hold stuff onto the frame. Okay, so oh well, now that I see it, would have made sense to put them the wrong way, right? The right way. The hole obviously needs to go to the bottom. Let's try this again. That's the downside if you design all the parts like mirrored, basically. So so far the printer is a perfect mirror left to right. But then everything kind of fits also in the wrong orientation, which is maybe not good. But yeah, obviously makes it also way easier to design because you only design one part, one side, and you just mirror it from one to the other. Yeah, but I kind of liked the working like this. So let's do this again. Okay. Yeah, getting everything square at the end will be quite a fun task, I think. Front ones. That's also my purchase list for stream equipment. It's like a longer boom arm that can like go up a little bit more. Okay, this looks better. Then now the fun part. But I think actually it's quite easy to get the back part off. So we just need to loosen these two screws, and this screw, and then we should be able to just pull it out. Let's just actually remove the vertical. Oh, we just need to pay attention, right? Because we now have these bearings here. They will also drop. Ah, even better. There are screws here. Have you published the project yet, or are you still waiting, or never making open source? I definitely make it open source. It's just like it's not ready yet. Very, very simple. Like, I'm not done designing it. So yeah, it doesn't really make a lot of sense at the moment to publish it because it's just kind of useless, to be honest. But yeah, it will be definitely open source once everything is ready. I'll most likely just upload it to printables. Nope. Okay, we actually can maybe leave it like this. But yeah, I'll put it on printables. That's my idea. Just like all the diffusion file and the step file exports. Let's try to keep this in one, maybe. We have a little bit easier time later reassembling. One thing I did not publish yet, and I really should, is the PC case. I thought about it like the other week. But I also still didn't quite finish this one yet. Maybe we can do one more stream on the PC case. I mentioned it before. Now that the ender wire is up and running, I can print the rest of the parts. Hi there from South Africa. Hi from Netherlands. Oh. So basically for this corner here, we will replace the teal part, and we will replace this black part that holds the motor. And that's actually what's printing at the moment. And looking at it, it needs like another 20-25 minutes. So with cooling down a little bit, like let's say like 30 minutes, we need to wait for this part, which is a bit of a bummer. Which is a bit of a bummer. I totally forgot, like I was like, oh yeah, I only need the teal part to replace that. And completely forgot that I changed this part. So basically what I did is I made it a little bit, like this is quite flimsy. So I made it a little bit like thicker to have more support. But now like looking at it, what I could also do, because I really gave up on using those like small shitty motors there, I can remove those cutouts here. And that would make it also a lot stronger. But in the end, it doesn't really matter. So it's more like about the flexing, because like it's locked in place on 4 points anyways to the motor. So I'm actually not sure if we need to work on this at all. Yeah, Kublik, that's the fun of prototyping, right? Like I just replaced this part because I changed it. And I'm constantly doing this. I don't expect this to be the final iteration of this part. So as long as I do that, like it doesn't really make sense to publish anything. Because like if you print anything of this project right now, I guarantee you it won't be working in the end. And I hope we're slowly at a point where like at least like functionally it's complete, but yeah, I'm not quite sure if it will be like working as expected yet. Let's clean this a little bit up. So this part is actually quite interesting because it prints like this. So it basically like these are all overhangs. And I really struggle with this Polymaker ABS to get the overhangs right. I printed the same part. I don't have it anymore. But like 2 weeks ago, I printed the same part with another ABS from Redline filament, and it printed much better. So I kind of regret my decision with the Polymaker ABS here. And I'm pretty sure that for the final, like, I will most likely print all the parts again. So these are really like prototyping pieces. That's how I see it. So when everything when this machine is working, I want to build maybe not the second one because I want to like buy all the parts again. But I want to rebuild it basically with like the final parts to see that everything works. That there are like no issues in the parts that I added over time. So, and then for this like proper build, I'm pretty sure like the Redline filament is quite high on my favorite list at the moment. They also have pretty sweet colors. It's a bit stupid to clean. Yeah, but basically because it prints like from here, this is basically like a 90-degree overhang, so you need to support it from the bottom. So I have these inbuilt supports, but yeah, it's a bit difficult to print. And yeah, basically before this was all one solid part. So these were not super strong. I mean, they're strong enough, but now this is printed flat to the bed, which makes it much stronger and also easier to print, to be honest. It's just like now you have the cut here, which is not ideal. Yeah, obviously I know that you do many iterations. Yeah, I think it's like also like maybe that I don't want to count, but maybe like the 4th iteration of this part for sure. Just like changing like stuff like this. It's also because I don't design the printer. Like maybe I should have done that. You know, like just sit down and design everything, and only when everything is virtually like there, that like, you know, like I have a complete 3D model of the machine, then start printing. But I'm pretty sure if I would have done that, it would also have gone horribly wrong. Because like the assumptions I had in the beginning were just wrong, right? Like you plan something in your head and then like you redo it and it just doesn't work the way you expected it. So I'm pretty sure if I would have done that and just designed everything, it wouldn't have worked on first try for sure. And then going back and redesigning everything would have been like much more painful. And I'm pretty sure that I would have just dropped the project at that point, like because I would have needed to make so many changes. So I'm pretty sure this iterative approach I have now is quite good. But yeah, that means you need to go back and just add things that you completely forgot, like the idler for that. I mean, not necessarily even forgot, right? Like I just didn't know that I needed the idler to be there. It's actually quite okay. Like so far, I think I printed like maybe like 400, 500 grams of the teal ABS of this one. The black one, hard to say because I also use it for other things. But maybe 600, 700 grams of that. So I'm not wasting. I mean, I'm wasting quite a bit of filament, but it's not horrible. Also, in the beginning, I printed a lot of parts in PLA. All in the beginning, and that PLA I all gave to recycling. It's not quite in. Okay, 3 more to go. And then one extra new. Yeah, I totally underestimated how difficult it is to design a printer. Yeah, I was like, yeah, I mean, like it's difficult, of course, but I didn't expect it to be this difficult. It's just like now, like a bit of excess filament around the heats and inserts. Okay. Oh, okay. Cool. Then this is one part. Oh, we forgot the plus one. The fresh heats and inserts look so much nicer. Like this looks so clean and nice. And these are all a little bit like weird. I don't know how to describe it. Like there's like, yeah, filament bits still on there. So yeah, but yeah, you can reuse them, of course. And for me now, iterating over those parts, I definitely try to reuse as much as possible. So then, oh, we used still the silver screws there. I thought I had everything switched over to the black screws already. Yeah, but seemingly the corner pieces I forgot. Okay, so this goes in like this. Can we already, yeah, we can already mount it. We can just not install the motor yet. Make sure to not tighten this yet, so we can like slide the rods in. Yeah, this knot doesn't fit very well with the heat set inserts. But we'll figure it out. Now also, like, I'm not quite sure why I didn't do this at the beginning, to be honest, but wait. What happened there? Oh, that's why it doesn't fit nice. I accidentally swapped those two parts. No. Wait. Oh no, even worse. This is the part for here. I did the wrong side. Well, let's do the other side. And we have another 15 minutes anyways until the motor mounts are there. So I tried printing this part without a brim, and I wouldn't need to clean up, of course, but this is like then all the contact area for the entire part, which is quite a feat if you can print that, to be honest. This did not print well. There's like a lot of... I think I printed the teal ABS a little bit too hot for quite some time. I think I need to find a better solution to supporting this, because like peeling this part out here, like these supports, is like really annoying, to put it frankly. Okay. Yeah, let's just take the other side apart as well. Just keep the screws where they're supposed to be, and we can also remove this then. But yeah, what I was thinking about is like, I don't know why I had these parts separate, like these black parts for top and bottom. Like, it would be so much better if these would connect, if this would be like one part, because then like it would make it like much easier to assemble because you have a set width here. And I think it also would make it a little bit sturdier, maybe, I don't know. But for sure easier to assemble, so I'm pretty sure that I will redesign them at some point to be like one block. I'm not quite sure like why I never considered before like making this one part. Hmm? Ooh, I was securely mounted here. I'll take tip there. That worked better on the other side. Just trying to not lose all the shims. Okay. Save these. And here, let's also swap the silver screws for the black ones. Benefit of the new design is, like at the moment, you cannot remove the motor from that mounting. You always have to unscrew the mounting plate. Now that the end part is separate, like you can just pull it out basically. So that will make assembly a bit easier as well. Okay. Yeah, and last time we used like mismatched motors and stuff like that. So by now, like because we disassembled or like we removed the motors from the end wire, we have like tons of those Creality motors. So we can choose what we want. Okay. Let me quickly like remove all those shavings. What's there? In 3 minutes, the motor mounts are done. all in perfect time then. Get rid of the extra filament. It came with the reused heat sets. Basically like inbuilt thread locker. There's a bit of filament in the thread. Yeah, it doesn't want to go out, so let's leave it there. I actually need to go in a bit more. Okay. Definitely less work to just use new ones, to be honest. Okay. Let's put everything back together. There's still like a lot of excess filament here. It needs to go a little bit deeper in. No, it's good. So now let's pay attention that we use the right one. So long gap, long gap. So these fit together, but it's the wrong side. This fits here. So basically they're all unique. They just look the same, which is not really helpful. Then this one fits here. So this part is complete. Back in order. And then this one must go here. Oh, interesting, that changed. Oh, this part here has a shorter, like it's shorter here, right? Compared to the others. The others are all longer. So this must be like an old part I accidentally left in and didn't replace. I mean, it fits. It's just the shape is a bit different. Yeah, that's why there's this like mismatched shape here. But yeah, not important. As long as the screw holes match and everything, I'm totally fine. But yeah, it's not on this side, so it's really just black part. That is like an older iteration. Cool, yeah, so now we have these parts, and then the end caps are basically just like put on. And the screw of the motor mount will basically just push this in and hold it on. So there's no glue or screw needed to hold this in. Cool. Yeah, let's just put this back together, and when this is on, I think we can take out the parts from the printer. Hi there, Halim. Oh, let's make sure. Oh, we forgot one heat sensor here, the new one. Let's put this in. Okay, so let's get this straight. This should be correct. Let's see. It doesn't matter right now which stack goes where. You just have to do them opposite on each side. Actually, I'm not sure if it would be smart to first leave those parts off here on the side at least. Because what we can do is we can screw this in and then just rotate it over, which makes everything a lot easier. It will also make it easier for this bearing stack. Ooh. Well, that was the end of this bearing stack. I wonder whether I had a smart trick to do this before. I think the answer is no, but maybe I should come up with a smart trick to do this. But this is not really ergonomic. Let me also check. Yeah, there are two shim washers in the center, not only one. We have shim, bearing, bearing, shim, shim, bearing, bearing, shim. It's a very awkward way of doing this. See if we find a better way on the other side. Let's try to fill this in. Okay. The screws in. It's not over tighten this, but then at least it gives us a little bit of like alignment help. Then this can go in. Oh, what happened to the music? Let me also take this chance. Quickly switch the side. Okay. So then let's see. Let's do quickly the other side, then we can connect them on the back. So this goes in like this. Okay, let's see if we can find a smarter way of doing this. Oh yeah, I remember the smarter way. Smarter way was to not secure this here. Either Renovik. So let's try it again. Okay, so maybe it's not best to assemble this beforehand. Basically this screw goes through here and then we put the stack on top. And then we can screw this in like this. And then because this part is now loose, let's see if I can. We can put the screw through here. And then put the stack on the screw. And now this is much easier. So perfect. Now we can put the side piece on. And for the back, let's just remove one side. And quickly see if I can get rid of this tape. What bed are you using for this? The Prusa mini bed. So it's 180 by 180. But technically you can scale it up or down. So you can technically use a V0 bed, like 120 by 120. Or you can use an Ender 3 bed, something like this. So I kind of have it in mind, but let's see if in the end it will actually work to scale up or down. I think the tricky part for the smaller version is where to put the electronics. So there might be a creative solution might be needed, let's put it like this. But scaling it up for Ender 3 technically should work. I mean, I'm still like very uncertain if this entire concept with the rods works at all. So potentially it just doesn't work. And making it bigger definitely will make it harder. Maybe I actually should have built it in Ender size with a 220 by 220 bed. Or no, the Ender is 235 by 235. Oh. It's all tight. We don't forget to tighten any screws. Oh, hilarious thing happened, right? So last stream we were like switching out the hot end of the ender wire, and I'm not sure if anyone watched it and remembers. I struggled a bit to push in the Bowden tube in the there's this like hole basically where you push the Bowden tube in over the heatsink. It's like two parts clamping together on the Bowden tube. And I couldn't push the Bowden tube in, so I loosened the 4 screws holding the hot end. That also clamped it together. And seemingly I forgot to tighten those screws again, so the hot end was completely loose. And I was like going crazy for like a couple of hours while the extrusion is so uneven. But yeah, it was just the hot end being loose. And for some reason, like, I mean, it should have been the first thing I checked, and I didn't. So it was a little bit of like a waste of time. But that's the thing, right? Like, right now, it runs really smooth. But before with the belts, it was like, there was like these like points of like where it just like locked into place. So I'm really certain that like the issue was the belts. And I'm also not quite sure yet. So, I mean, it will be better if the understuff's there, but like it's really easy to twist it at the moment. So this will be like a little bit of a challenge how to like straighten this out. But technically, if you have like this is not perfectly level, but if you have something perfectly level, you can just push it down. Is there going to be an enclosure plate? Maybe in the version 2, I don't know. Like, I'm not quite sure how you would enclose it, to be honest. I thought about you can use those as mounting points basically for an enclosure. That those screws basically go a little bit further out and you can like mount an enclosure against it. So the sides are easy. It's just like this part is a bit hard to enclose. I don't know. So answer is so far, I don't know. I think it would be cool. Yeah, let me quickly get the parts and I'm right back. 1 second. Totally missed your message, Rivonic. There are some external electronic boxes like the one of the Stinger. I don't know that, but yeah, it reminds me a bit of the CR10 times. So yeah, technically, when I made this thicker, something went wrong seemingly. I already wondered when it's hard to print, but so basically this the bottom of the thread was cut off, and now it's not as cut off anymore. This one printed fine, but this one really warped away. So we need to see if we can get this to work, or whether we have to reprint that. Oh, but it actually seems to work. Okay, I will reprint it, but just like for now, generally quite stiff. That did not print super well, but it's functional. We can use the part for now. Okay, so this side is okay. This one also has a lot of friction. Yeah, that was not my intention. So I need to work on this a bit. That's the thing, like sometimes you change like one thing and like something completely different changes. Let me just try to get this like hard edge here where the thread meets the bed away, and then potentially this helps already make it run smoother. Yes, much better. It's a little bit stiff, but technically, if that is a bit stiff, like it's more like a feature than a bug, so it doesn't as easily change itself. Yeah, if you run this up and down 5 times, it also will be much better. Cool. Then let's pick our motors. So we have tons of Creality motors. Let's see. So we have. Maybe we should even just use those two. I think these are the. Yeah, exactly. So they are the small. Oh no, this one's also the larger one. We have the taller ones and the small ones. Now I wonder which one I should use. I think like the Ender original use those for X and Y. So they should be good enough, I guess. But yeah, let's just use what the big ones, the tall ones. Just use these two. LH Stinger is a super high-speed bat slinger, like faster than Warons, but open air and doesn't have any spot for electronics, so uses an external electronics box. Also, it's really like the CR10, where you had like these like external compartment basically that just runs the cable. I think by now, like you could do this actually quite nice with Canvas, right? So it just would run like 4 wires to the main printer, like just like the plus minus, and can high, can low. That actually would be quite a cool setup actually. If you have it like, you know, in the past, you didn't have this like massive cable loom. Like I think that's kind of like stupid, but yeah, I think it could work. Let's see, what kind of screws do we need here? I think the M3x8 are a bit short now because I made it thicker. To be honest, I'm not sure if this was like the best move. So this is the old part, that's the new part. So we just made it thicker, and it's like much sturdier, but I'm not quite sure if it adds a lot, to be honest. So let's see, maybe we can use 12. Yeah, I think M3x12 should be good. No, yes, all of the normal cables. Stepper motors can. I mean, technically you can do it, Steve, right? Like if you have, well, then you need to have a stepper driver board, which maybe defeats the purpose. But I mean, like you technically only need, assuming you have like toolhead board, right? But I really don't know the printer. But yeah, technically you have breakout boards with Canva steppers. So I guess you can do that, but then again, like you have electronics again, so it defeats the purpose a bit. Oh, the 12th might even be too long. Oh yeah, 12 is too long. Huh. Yeah, ever so slightly too long. Then let's stick with the 8s, and it's just like not going super far in the thread, but I think it's fine. To be honest, I think you're all quite strong enough once to screw the motor. Yeah, I think the same, Steve. I think the same. I think there was not the best move to like make it thicker. It was just like it felt a bit wobbly, so I wanted to make it a bit thicker. Yeah, I think the 8 and 3x8 just work. Yeah, so I might undo that, to be honest, or maybe find like a middle ground between the two. Also, what I mentioned earlier, like those cutouts here, which were for the other motor type, like we don't need them anymore. So I can also make this like just like go through, which also makes the part stronger. But yeah, like, I mean, now it's on. The only thing like what happened before with the old part is like when it was on the motor, like you could kind of bend it up a bit. So this part now is like stronger in this direction. So that there's a reason for having that, to be honest. Because like there's like later there will be like the pulley will be forced this direction, right? And this part holds it in place. So I'm not quite sure, to be honest. I think it's not needed, but nice to have, maybe. But yeah, that was my initial thought as well, why I never made them so strong in the first place. It's like, yeah, they're like screwed in on all 4 quarters to the motor. Okay. Let's see, I'm not quite sure about the pulley, but I think both pulleys can be upright. Or is it smarter? Let's do one pulley upright and one pulley upside down. I think then we have the maximum. Let's go check when they're in. Because I can't remember how we had it before. Okay, so the new improvement is now basically you can slide them in with the motor installed. Before you only could attach the motor when they're in there. And then this end piece comes on top. And then the screw just fit. There you go. Then basically you screw the end cap on here. And what happens basically is the belt will pull the motor towards this direction, right? And this mechanism basically will pull the motor outside, like this direction, so you can tension the belt with it. And now you see basically, because the belt in the end will hold this like end cap on. So I think that's sufficient. Just put them in a position that the motor basically is at the end position there, and later we can tension them. Cool. Yes. Then, to be honest, I wonder whether we should put the legs on today or whether we just leave it standing here. Technically, it should work. It's a bit easier with the camera. So we can just have it here. Might twist a bit. Let's put the legs on. Let's put the legs on. It gives it a little bit more stability. So, oh, we have to loosen that again. Shall we push this all the way in? I think it's also smart to assemble like the x-axis later, because then it like, now it's like super wobbly because this part is a bit higher. I think it's nice if it's flat on the table at this stage. So if I ever write a manual, and it won't be like a Voron level manual with pictures, but I think the x-axis should be one of the last things you assemble. So first you assemble the entire frame, and then, because it's very easy, just like the screws here on top, and then you can like take out the center. Okay. All the way in. But it's nice, by now the parts are all designed in a way that you can tighten the screws quite aggressively, and like nothing splits. So at least we figured that out by now. Okay, so I have these temporary parts here. So what I would do is, let's just try to like put a square to the bottom, that like the legs are basically secured. I hope I have enough of those clamps for that. Might just have. This is all temporary. Let's just first. No, I don't need to. Technically, we can also do like one across. See how much clamps we have. So this one goes to the back. Right. Okay. We don't need, these ones are ones with linear bearings inside. Don't need those for now. So we just like to stabilize it a bit. This and the last one. Okay, let me also quickly clean up my tools that I don't need anymore. A bit less messy. Okay. And I think this is somewhat straight. Let's just tighten all the screws. It's also something I should have done like a while ago, just to see like how sturdy this will become. Because like in the end, the bottom corners will be like better than this, of course, and they will have two beams per side basically. Oh, and I made very weird decisions in which direction the screws face. Okay. I mean, the surface is not super straight, so this is not perfect, but for testing today, it should be fine. And like, yeah, it helps quite a bit with the generally stiffness, and now you cannot easily rotate it in anymore in this. Oh, you still can. Oh, because those can, okay. So you can still push it because the corner pieces are not connected. So once the corner pieces are also connected, this will be fine. Okay. Yeah, it's the thing with those rods, like they always rotate and twist. But yeah, like once those corner pieces are like the final ones and they're like properly connected, this should not be possible anymore. I hope. I feel like the frame would definitely benefit from cross-bracing. Yeah. I think later will be fine because like these are like fixed, like the corners. Technically, you can have like at least one going through here. That's something like you could add. But so I did a test with my V0 and I also like just pressed it in a certain way, like just in a couple of places. And also the V0 frame is not super hyper stiff. So I think it should be fine. Like we can check like once we have the bottom corners. Having a rigid frame would let you get better input shape. Yeah, for sure. Don't get me wrong. Like I'm not saying that's not important. I mean, for the bottom part here, it's very easy to add, to be honest. The only thing that we would need to check is like how Z-homing works, how the Z and stop works. But this could be very easy. It could be also add-on, right? That you don't have to do, but you can. Interesting would be how you do it for the side panels, because they're like there's. I mean, if you do it like this, you just lose like travel, basically. But yeah, that's definitely some. I thought about that too. I thought about that too. Okay. Let's see what we can do with belts. So first let's quickly check the orientation of those. Yeah, I think we have to put both. Yeah, both pulleys need to be up, like the right side up. Okay, and then let's just run the belts. Let me quickly grab one of the old shitty ones. Then we can just like get the length from it. So I just put them teeth and teeth. Oh, that might just be perfect. Once prefer aesthetics over structural rigidity. V0 would have been much stiffer if they didn't have separate top had, and they also had an extrusion in the front. Yeah, totally agree. That's also like one thing, like while like playing around with my V0, I also saw. And I also had the thing, like I didn't want to add this bar here, exactly for the same reason as the V0, right? Like it's just much nicer if the bar isn't here. You can technically add like V-shaped bars here and maybe get rid of this. But yeah, like technically you can also just add these V shapes here. It's just a question on how you integrate with the skirt. Hey Jim. If they connect the top end, it would require a slightly larger printer, but would make a lot more rigid. Yeah. But I wonder, like, if the top head is down on the V0, if that not already like helps it a bit. But yeah, it's not like super like rigidly attached then. So most likely not. So that's one belt. Let's get another one. More belts. Yeah, they feel so much nicer than these cheap, shitty belts. I just hope that the belts were really the problem we had in the motion system. Personally, I like how the Trident is designed. It still has the open front and it's decently rigid. Yeah, I mean the Trident is a pretty cool design in general. It's just like fancy but functional. Okay. Now we have two perfectly sized belts. I would say let's fiddle in both on one side and then run them. Wait, that's the wrong one. Not make the same mistake again I did before and put both ends of the same belt from the same side. That's number one. And number two. And let me quickly remove the other side. Now I can't remember anymore, but I think we already cut them flush, right? Before I removed them, they were like cut flush. So we also have to kind of like install them flush. Oh, we made a mistake. I was just thinking about it. Now both sides in the back, both sides have the bottom pulley, like the pulley here in the bottom. But one needs to have them on the top and one on the bottom. So we need to quickly flip one over. I did not pay attention to that. That would be like interesting operation. Make it feel like a little, oh, okay, it's a bit crooked, but you can have some enjoyment from me trying to get this in there. I'm actually not sure if this will work. Pretty sure this will not work. I don't feel like disassembling this again. Because that's the first... Oh, I feel like we have to disassemble this again. Let's see, how can we do this smart? If we loosen this, and we loosen this, no, not this. Oh, we definitely have to loosen this corner stack here. Wait, not this much. Yeah, like this. Okay. Now we have a better chance. It's still not a fun task. Okay, this does not work. Let's just remove this bracket here completely. Remove the motor. Remove this beam. Okay, lesson learned. Really pay attention to this one, because if you do it wrong, it's not an easy fix. Okay. Now we can assemble it. I'm not quite sure how I can show you this best. So we take the let's also let's just go the extra mile and make it really easy for us. Okay. Now we can just do it here. So just double check, yes, on top now. Just put an Allen key from the back and you can hold the screw. Okay, now this is back in. And now we can do the entire thing in reverse. I advise use Word HHS 2000. What is the Word HHS 2000? Is it like... I know Word makes screwdrivers? Lubricate. Oh, you mean for the bearing stacks? We used a bit of lubricant on there. We used... I forgot it. The lubricant I use for all the printer stuff. It's the one from the War on Rome. Totally forgot. Mobilux, I think. No. I dropped the stack. Cross building stacks is so much fun. Let's build some more stacks. Shim, bearing, bearing, shim, shim, bearing, bearing, shim. There we go. Let's not drop this again. This screw does not want to go in there. Okay. Let's make sure that we don't forget to tighten something. That's my favorite thing to do. Okay. Attempt 2. Put the water back in the bay. Here we go. Cut the... You mean this? Yeah, I mean, I can use a screwdriver, but I like my manual. My manual tools. I actually have like a small Bosch screwdriver that I used in the beginning, or like not in the beginning, but like at some point I used that. But I kind of prefer using just a hand screwdriver. So let's see if we get this routing correct again. So top one goes to the front. Around the front idler. We have to like go through here. We go around. Then we go into the motor bay here. Around the pulley. And back out. And then through the XY joint. And this is, I think, a belt run. And then I can like go in here. That is on the wrong one here. That needs to go to the top. Okay. That's one. Make sure it's like all nice and light. Oh, which is not. Here in the front it's not on the, now it's on the. Okay, I think now it's okay. Then let's do the bottom one. And that goes through the XY bracket to the back. And we go into the motor bay and back out. And we go around the back. Through the XY joint. Through the front idler. Y joint again. Oh, wrong way through the XY joint. Here we go. And then we go back in. Easy as that. Make sure we have an equal amount of teeth out here. And then we can use our end block here to hold everything in place. Okay. Double check. No, I had it a bit too tight already. Still want to pull one teeth on top, one teeth on the bottom. Now we can tighten them. Okay, kind of moment of truth. Oh, it runs so much better. Oh, crazy. I mean, I knew the other belts were quite shit, but I didn't expect it to be that much of a difference. It runs very smooth. Oh, it's actually like the belts are, I mean, we still have to tension them a bit, but looks okay so far. So let's just tension them a little bit so that the motors are off the end position here, so that there's a little bit of a gap, that we have somewhat of tension. And then I think what we can do, we built this like very fancy tool last time, right? I mean, I'm not quite sure what the ideal tension would be here. We need to look this up, but maybe we can go to like, yeah, I mean, now it's 2.1. Seems a tiny bit too loose for me. So how about we tension that to, let's say 2.2, 2.3? Let me see, which one do I tension here? The bottom one, so I need to tension this one. Pretty cool to just see it live. So that's 2.3. Okay, using it upside down is a bit awkward. But I think if we do to the front, that should be somewhat similar. Yeah, 2.3. And runs pretty smooth. I'm not quite sure about like the height of the pulleys. So this one here is pretty much on the bottom position now. So I'll just lift it up like a tiny bit. It maybe means we need to like lower one motor a little bit down. But for now, for testing, it's fine. So I'll just tighten them in this position. Just make sure it's like a tiny bit above. Anything? Just making sure that like one screw is on the flat side of the shaft. And now we have this. Cool. Then let me see. So if we want to drive this under its own power, what kind of random parts do I have to use? I do have a 24-volt power supply, so check. I have another 12-volt power supply, but we can use this little cable thing. So let's quickly transfer this over. bit janky, but for testing now it should be fine. That's the cable I have. That's the answer, Ender. That's the cable I have. That's okay because the outlet is right here. And we can just run like a pretty long 24-volt cable. But for testing, this is what I have available. Okay, so we have this. I have a Raspberry with a clipper running. I have the member over there. 1 second. Let me grab that. Wait. That is 3. So we have a semi-broken mainboard. We have some heat sinks for the mainboard. And yes, this is lacking one stepper, but we only need 2 steppers now, so that's totally fine. So, very janky setup. Yeah, that should be long enough. And why don't use cable caps? I will disassemble this again in like 5 minutes, basically. This is just for now. This is not something I would run long term like this, if it eases your mind. The only thing, again, we can't do is homing, I guess. We could set up sensorless homing. That should work. Like, we can set up sensorless homing. I think we can also connect the end stop switches. I just need to check if we have a cable for that. Safety first, yeah, I know. But to be honest, like, it's not like this will like fly out now or something, right? I mean, the cable caps will be better over time. But correct me if I'm wrong, the cable caps also are not worse than the bare wires, right? I mean, unless you now have like wires crossing over, which shouldn't be the case because of those guards here. The only thing you shouldn't do, as far as I know, is like solder on the tips and then put it in. Because the solder will like deform over time. But maybe I'm misinformed. So, okay, I do have some USB cables flying around here for the Raspberry. Will also be an adapter. Where are you hiding? That's the wrong one. This one is the right one, so we can connect the Raspberry to the main board. So that's checked. And then we need power for the Raspberry. Is that something I consider? Oh, okay. One of those cables has a... That doesn't fit. Has a right angle. Let's see. We have another micro USB cable here. I'm very well prepared, as you can see. I have the world's shortest micro USB cable. Oh, this one. Okay. So this would be all the weird setup we need. Then we need stepper driver cables, which I have a whole bag of here. I just hope that they are correctly wired. That might be again the issue, that the wires are incorrect. We had that in the past as well. So this is one stepper. No. Okay, let's at least compare the two cables. That the two cables are great. Is that a wizard's hat? Which wizard's hat are you talking about? Oh, you mean here on the side? It's a massive wizard's hat. Trust me on that. It's this is like my project box with all the stuff for this printer and some random weird stuff. And this is just like all the things I never clean up, including micro USB cables. That's like, yeah. Because like this is my dining table, so I always have to clean up after. So everything for me is in boxes, so I can just like put it in a box and like put the box away. So everything's box organized. Okay, let's see. Let me quickly check the multimeter out of my wizard's box. Let's just quickly check that those two cables are the same at least. I'm pretty sure that we used those two cables to drive the motors before. But just to be sure. I mean, here we can even see it because they're colored, right? So if they would be the same, the outside here, cable really has its own. Do I have anything to hold this down? No, not really. Okay. Okay, so outside should go to outside. So this would go here. Okay, I think they are. So these are the same. And then this should go here. Oh, they're not the same, I think. So these are over cross, but in the center they are as they are on the original plug. And here they are in the center. Let me verify that. So here the blue goes from one side to the other. The black is on both on the inside. Oh, actually they are the same. And then green, green, red, red. Okay, so they are the same. These are the same wire. So I'm pretty sure that we fixed them up before and that they're correct. I mean, worst case, the steppers go the other way. Just found you. This looks cool. Thanks, Matt. It's the project started a bit different. So in the beginning, I wanted to make like a very cheap printer for like under 100 euros, which didn't work out at all. So by now I'm just trying to build a printer, which already is quite challenging. Okay, so let's connect that. Use the socket. Oh yeah, I could have plugged them in. Ender, that's a good trick. I did not consider that. Okay, now technically we have two end switches here. So there's one end switch here, which goes over here, and one over here. So I mean, we can just whip up a wire, to be honest. Let me see if I have some. These are the wires from the from the ender wire. That's the old. Maybe there's something we can use. What kind of plug is there? I'm pretty sure we quickly need to crimp something up. Oh, not what I wanted to do. I don't even have my crimping box here. Okay, let's just take like a couple cables out of the loom and then just crimp the correct connectors on them, and then we can even home the printer, which would be quite cool, I think. The only thing, the Z, we don't have a Z axis obviously, so we kind of have to fake that. Oh, there's another stepper cable, very short one. Let's put this in the stepper cable bag. So let's just, this one already has at least the correct connector on one side. Cool, okay, this is one cable. And then let's take this one here, I don't know. And then we need one more. And then this can go down here. Okay, cool. Then we need to quickly crimp matching connectors to the end here. And we need to combine those two. And then we also have end stops. And then like for the Z end stop, I will just use the, Ender will love it. I will just use the screwdriver, and when it tries to home Z, we just connect, like we quickly bridge the two pins here. And then Z is homed, so that should be fine. Okay, let me quickly grab my crimping box, and then we can crimp some wires. Right back. Here we go. Let's crimp some JC connectors. See if we can get this out. Here we go. Let's So then these two are going to the same connector. It's already like, yep, going. Okay, so it's one side. They are, just quickly trim off the ends here, that's the same length. Here's my trash. You will get stepper fault on that as it's not connected to a stepper. Well, the board doesn't know that there's no stepper. I mean, technically we can also have like a million steppers here. We can connect the stepper, that's not a problem. We can actually do that, then we see when it moves. But the stepper driver has no idea if there's a stepper or not. There's no feedback. That's actually like the problem. You know, like when you lose steps if you have a layer shift, right? The problem is the printer doesn't know that it lost steps because there's no feedback from the stepper. So that the stepper driver just sends like power to the stepper, but if there's a stepper or what the stepper is doing, the board doesn't know. Right. So you can totally drive this without steppers. Doesn't work, of course, for obvious reasons. Let's see. I removed a tad too much isolation. My crimping mojo is not yet activated, I think. Why is this not going in there? Yeah, I'm not quite sure if this like connector was weird, but like this was not going anywhere. Try it again. Yeah, okay. I would say the connector was weird. Let's try the other side. But yeah, for the stepper discussion. So there's actually like something called a closed loop stepper. And these are basically steppers that have electronics basically on the end of the motor. And for closed loop steppers, the stepper monitors if the commands it receives. Once again, weird. Okay, I'm not quite sure what I'm doing wrong. If the stepper, like if the commands it receives are actually like resulting in the appropriate motion. So they're pretty cool because like they can recognize when you have a layer shift and they can correct for that. This one's fine. Okay, I don't know. Let me quickly see. Like I just saw it's a 3-pin JST. Okay, I think I remember it's the two outside ones of a 3-pin JST. So let's just go by memory. Okay, so this is one end stop cable. And we had a second one here. Make sure they're kind of the same length. I mean, it doesn't really matter because like this is just like a temporary cable that we'll use for like 5 minutes, basically. Looks good. Maybe my crimping mojo is powered up now. No, this one's getting weird. I never had it. Like, it just bends them to the back. It just bends the legs to the back. I don't know. Again, I don't know what I do wrong. I never saw it bending the legs back. Like, it was sometimes a bit weird, but never bent back like this. At least it's the last connector for today. That's what you're talking about. Hopefully. I wish I have a stream at some point without having to crimp any JST connectors. Okay, this one looks good. Mission accomplished. Let's put this to the side. Okay. Oh, wait, I still need the housing. And this housing can go back. Okay. And then this can go to the second. So there's one end stop here, basically. Oh. Okay, now it's on. So this can go in here. Should see it. I just dangle the cables down here for now. And I have to figure out how to route this cable. For now, something like this is fine. And then the other end stop is here in the center. This is that cable. Where did I put? Oh, over here. Right. Yeah, this later will go like by the cable loom, of course, but for now, just down here is fine. Okay, then this one is the X end stop. And this one is the Y end stop. You will get step of, I find it better to me to have the JST in the crimp tool lock. There, feed the wire and then crimp it all on. Yeah, like usually what it works better usually. Like what I do is I put the metal crimp thingy on the wire, and then I use the one pair of pliers to just like push it together, and then it holds on, and then I can crimp. Usually it works quite well. I'm not quite sure why today it decided to not work well. Okay, let's see. So let's plug in the Pi already. The only problem I have, because I have the power switch here of this like outlet thingy to turn the printer on and off, but then I also kill the Pi Let me see. Can I plug this somewhere in somewhere else? Oh, I can plug it into my USB hub here. Okay, Pi is powered via my laptop. That already powered on the main board, so now we can technically already check everything out. And then I'm plugging in the power supply. Okay, now just like for you to see what's going on there. So I have this extension thingy. This is my soldering iron, so you can ignore it. This is now the printer. I have the switch here to turn it on. The Pi is kind of flying around here on the side, and it's powered via the USB hub there. So that's not a very professional setup. Make sure this like AC stuff is kind of like on its own a bit. I have like tons of cable here. It's totally fine. Somebody requested a third stepper. Here, I offer full extruder. And we found a very short cable, so we can plug this in. Oh, there's one problem. I mean, there's no housing, but I mean, it doesn't really matter. Okay, so this is set. You have 5-volt jumper in place for the Pi to power the mainboard. I don't think this board has a 5-volt jumper, to be honest. I think this is just how it is. There's this red jumper, which might be something, but I can pull the red jumper and see what happens. No, the red jumper is not 5-volt. I don't think this board has a 5-volt jumper. Okay, let's just see if we can find that bad boy. I could remember how it's called. Let me quickly check in my router, because I completely forgot what host name I gave that. It was something tests that I remember. Mainsail.test. Yes. Here. Mainsail.local domain. Okay, MCU unable to connect. Yes, that is not configured for this one. So let's now figure out the things. Oops. Why nothing found? Okay, no clue what now. Now also the red LED, so did I now do something wrong? Cable not properly plugged in? Ah, cable not plugged in, okay. Let's see if we now find something. Yes. Ah. So if you plug it in, it actually works. So let's copy this. Just make sure it's the same one. Yeah, it's the same one. then now it should at least be happy with that. Cool. Okay, then we kind of need to configure stuff here. Firstly, because the steppers are messed up on this board, we need to swap the steppers a bit around. So this is a SKR Mini E3. I can also like pull the laptop a bit closer to me. E3 V2. Oh, yeah. Yeah, V2. So let's just quickly check this out. So for us, I need to see like we use stepper Z and E for the two steppers here. So stepper Z, we just need to copy the pins here. And the UART pin down here we also then need to change. So we go here for stepper X, so we paste the step pins. And the UART pin is 11. And the TX pin is 10. Oh yeah, oh, this one uses UART. So basically the UART pin, TX pin is always the same. And we need to pay attention to the UART address. So UART address now is 1. So that's X. Y, we need the values for E. So the pins here and UART address is 3. So Y, we paste the pins and UART address is 3. Z is actually Y, just for like fun mixing stuff up. So we copy Y, paste that here, and the UART address is 2. And that leaves the extruder, which is now on X, which doesn't really exist because there's no stepper driver on the board. But just for the fun of it, let's put this here, and UART address is 0. Okay, so the steppers are now aligned. Let's quickly check the end stops first. Once this is back. Did I unplug the board again accidentally? Oh yeah. Okay. You need to be really careful not touching anything. This USB port is very funky. Okay, so then we can query the end stops. So Z is triggered. Not quite sure why end stop Z is triggered. There's nothing plugged in, so I guess it counts as triggered. Let's push the Y end stop. Now Y is triggered. Hey, the end stops work. Yay! Oh, you don't see it, but you see the green and red there. So basically end stops work, so that's good. I guess it's something that works. Z end stop triggered might be a problem. I'm not quite sure why this is triggered. Let's quickly check what the, because I just copied stuff. End stop pin is PC2. Maybe we don't have to negate this. Let's just quickly check in the original config. Stepper Z, end stop pin is PC2. Reverse and clipper there, NC. I mean, I can invert it. That's not a problem. Is it like this? No, that was not the way. The exclamation mark comes after. see if it now works. Okay, now the Z and stop is open, and if some horrible person does that, wait. Oh, I moved the board again. Okay, this is really horrible. I don't know why this is so bad. Firmware restart. Restart. Is this a Clipper bug again where it doesn't restart anymore? Pretty sure it's there now. Yeah, the thing is there. Just doesn't restart. Okay, let's still reboot. Okay, so I cannot touch the board seemingly, because if I touch it, then bad things happen. Okay, never mind. We'll figure it out with that. Try again. Okay, this will take a second to reboot because it's a Pi 0, so not a rocket. Cool, but I guess what we can do is we can turn on the PSU, hope that nothing explodes, and then we can just do quickly like a stepper bus on each stepper, and just see. But it's amazing, like now, this like problem I had before that like it locked in a certain position is completely gone. So this entire problem came just from the belt. And I shouldn't do this too much because otherwise I fry the stepper. Okay, now we are back, magic. Then here you get the full close-up. Three, two, one. Nothing bad happened, so I guess that counts. By the way, this is the board where we performed operations to remove the broken stepper driver. And we tried to replace one. Oh, the Z stepper doesn't work. Hey. Okay, this is the problem. I totally forgot that. Ooh. Okay, I don't think we can use this board. Let's quickly do stepper bus for E. No, X. Stepper bus X. You see it? It's buzzing. So that works. Stepper Y. I see a bus. So this works. The problem now is we only have two steppers. And if we want to do home, I mean, what we can do is we can try to home X. Let's try to home X. Okay, this doesn't quite go in the right direction. Maybe it would have helped to change the kinematic system to Core XY. I have the same board, my USB, and my X stepper is broken. Yeah, like this one has two broken steppers. I have to serially communicate with the board. Right now, I'm only using it for a single Z motor. Needed because I have two Y motors now. Oh yeah, so I also use this basically as an extra board in the ender wire to drive the second extruder. But yeah, same thing. Let's quickly check. So there's a printer here, and the kinematics would have helped to set it to core X, Y. Let's actually check Clipper without Z. Is there like a... Okay, so they're not supported at the moment. Because that was my idea, like maybe there's like a plotter mode. Let's see. Okay, but now we have core XY at least. So let's quickly check if we get X home. Potentially it's just moving the wrong direction. So. Oh, X and Y are switched. Oh, okay. Okay, so that doesn't work at all. So if it moves, let's just quickly check the Voron getting started. Okay, so we have this. Oh, sorry, you don't see it. We have this one that you even now don't see. So X goes here and Y goes down. So both steppers are inverted. So what we need to do is in the printer config for stepper X, we just invert the direction pin, and the same for stepper Y. Now we can do X. Still moves forward. Wait, let's quickly check. There's a trick. Let's see if no, I don't have it enabled. So there's a force move section. I think it's enabled true. See if it wants that. You inverted stepper pin, not tier pin. Okay, let me quickly check force move. And then Steve, I think you might be correct. Enable underscore form. Okay. I mean, I was close. I inverted deer pin, you said. Let's quickly compare with the original. So we look for stepper E. Let's quickly check. This one had... Yes, you're correct. So I inverted the step pin. And then for X, we look for Z. Yes. I don't know why I inverted the step pin. Very nice catch, Steve, as always. Okay, but what we can do now, because we have the force move enabled, we can say set kinematic position x0 y0 z. Let's not set 0, let's set 50, I don't know. And now you see like a jump to being homed. So it now thinks it's at 50, 50, 50. So now we can step through here a bit. Yeah, but still doing the exact same thing. Y moves this direction, like here, and X moves here. Let's quickly check again. let's check again. So in X positive moves forward, Y positive moves to the left. X positive moves forward, Y positive moves left. So stepper B, which is E, is inverted. Okay, then let's just invert stepper E, which, God, which one was that? Step pin PB3. So the Y is, let's just, this is B and this is A. So here the direction pin should be inverted. Seemingly, let's give this a shot. Okay, Y moves now forward, so that's something, and X moves in the wrong direction. Y moves forward. Yeah, now it says both are inverted. We were here before. Okay, let's quickly invert both. So bit weird. See what happens. So, okay, X is fine, but now Y is inverted. Oh, no, Y is fine. Ignore me. Y is fine. To the back is positive. Yeah, we are good. Yay. Okay, so that's fine. Then I can home X. And we need to set it to home to maximum. Position end stop is it's not 235, it's 180, I guess. Position max is 180. Position is 180 and position end stop is 180. Let's try again. So that works. Problem is, if I now do like anything with Z, it will die. So if I do stepper bus or stepper Z, and because stepper Z is broken. I tried to like desolder and resolder the stepper like a million times. I kind of gave up on that. So we can move it a bit. I hope that we can use the speed test macro. We can maybe modify it. So if we go to Alice tuning guide, and then there is in the advanced tuning, determine maximum accelerations and speed. There's this macro, which we will copy. So this will just basically move the printer in a certain pattern, and we can determine the speed of that, which is quite handy. Do I have a macro? No. Okay, let's just poop it to the bottom. The only thing we need to do here, so this is just random stuff. We can just, whenever it says G28, which is homing, we just need to specify X, Y, like this. So we don't want to home Z at all. No touching Z. So G28XY. Okay, and then we just need to check that it doesn't move in Z at all. Yeah, this is for quad gantry leveling, which is like the 2.4. I mean, we can just delete it. So we're just looking for Zs here. So this is Z. So we just don't move in Z. No Z, please. There's no Z here, no Z here. And that should be it. No more Zs. So technically we should now be able to use this macro to move around. I'll just quickly check again how to use that. Exactly. So we set there's also a speed parameter, right? Yeah, speed. So we should be able, I mean, acceleration, let's just put this to like, I don't know, 200 and do one iteration. But technically what this should do is it should like home in X and Y. And then it should like start moving the printer. And we can just observe. I just hope that it doesn't touch that and is happy with that. It seems to work. I mean, it looks good. Like the first move was quite fast already. I think that's a really good test, actually. Cool. That's good. So there was acceleration 200. Let's just go up a bit. 1000. Okay, I had some nasty vibrations. But it works. So there's some resonance frequency, I think, when it does the move to the side. Just try it again. Let me just also like hold it a bit, because like it's very lightweight. Yeah, when it does the X move. Okay. So basically when it moves in X and in Y, like not diagonally, it has this like resonance vibration. I'm not sure if it's bad per se, like it's a bit annoying, but I mean it moves quite well. Like there's no like bad vibration. Nice. Would more weight help with vibrations? I'm not sure. I'm pretty sure like right now it's just like, you know, it's just like a frame and it's very top heavy because there's nothing on the bottom. I'm pretty sure that weight would help, but I'm also not quite sure what causes the vibration. So let's just quickly try like 2000 and see what happens. Maybe there's just like a certain frequency. By the way, I have the same on the switch wire. The switch wire has the same thing in Y only. So it would be nice to figure out why it has that. Let's see what happens with 2000, and I just hold it down. But it works way better than I expected, so hey. That was less than with 1000, so maybe I don't know. Let's try 4. I mean, the movement itself is fine. It's just like it causes this like resonance frequency. So I'm not quite sure. Because if I move it by hand, which I actually, by the way, should not do because it's plugged in. I'm not quite sure what would cause that. So if we, let me quickly home X. And we go, by the way, it's like perfectly 180 from one side to the other. Like it just docked here. So if we now do like a move, G1 X 175. Let me just quickly try that. It should just, yeah, we'll just move to the other side. Okay. Move out of range. Oh, it's G90, absolute positioning, G1, X0, or X5. We were in relative positioning, so I was adding that. So now I can move it back and forth. So let's just try, I have no clue about feed rate here. I have no clue, 4,000? Oh, 175. Okay, that's feed rate 4,000. Let's do 12,000. Oh, that was 1,200. Let's try again with 12,000. Oh, you can't hear it. It's so good. Microphone, filters. Now it should be off. Let me double check that the operating system doesn't apply noise cancellation. It's off. Okay. Now you should hear it. Let's do a test so you can hear it. That's just the speed macro again. Now you can hear it. So it's really just like this resonance vibration, I think. I'm not quite sure if that would be from the bearings, because like on the end wire I have the exact same thing, like in the x-axis, like when it moves at a certain speed it gets really loud. It's the same like kind of like noise. So not quite sure if there's a fix for that. So let me just quickly see if I can. Oh, now it's back in. Yeah, exactly. So this is basically exactly the problem. belt tension. Do you mean too high, Steve, or too low? I've heard of that with some specific motors, like just a certain range resonates. Yeah, that's the thing. But here now it's like a quite wide range. I don't know. We can lower the belt tension and see what that does. Just like for testing, I just ruined the tension. So it will be like very floppy. So now it's very, very loosey-goosey. Definitely better, but it's still, you hear it. I wonder whether it's like a lubrication issue. Hey, listening in the background, it's probably the two bearings fight each other through the range movement. To test, you can loosen one of the bearings so it floats. You may need to load the second bearing with springs in the housing. We can easily do that because basically for the X, we have the system that basically the back bearing is very, like, it's not constrained as much in X direction. I mean, we can just like loosen this here, right? Maybe we can keep the screw in. And we can also loosen these. So now the bearings basically are independent of each other. And hi Wes, by the way. No, it's still the same. Still the same. I mean, I can completely... Can I remove the one bearing here? Just trying to like get one bearing completely out. What holds you together? Okay. Now it's one bearing. Yeah, I'll be careful, Wes. I already thought like, do not double tap now up to do this. So now we just changed it from 5 to, I don't know. How long is that? Let's do 40. Very slow test. Yeah, 40 is fine. So, no, it still vibrates. It's the same. So basically, if I increase the tension here again, it will be louder. Let me quickly make sure I have like somewhat equal tension here. Okay, let's quickly now it's louder again with higher tension. Hi there, Nadir. Bolts and bearing, are they looped? Yeah, the bearings are looped. And these were the good ones. Because I sorted through. It's a standard ball bearing, so they are balls, and I expected it to be a bit loud, but not this loud. And I think I also paid attention, like now it's gone, but like that the balls are in the X pattern, that like no ball is like directly on top. And we can try different bearings quickly if you want. Let me grab bearings. 1 second. Okay, so I have random ass ball bearings here, but I don't trust them. I labeled them shitty, so I don't think they're good. Oh, I also have like some more bearings here, so we can also use those. But what I do have are these. So let's just try if that makes a difference. They are all packed with grease. I did that in the beginning. I packed all the bearings. Let's see, I think we have to take this apart here as well. Like they're all pretty packed. We can add more grease and see if that makes a difference. I don't think it will, but I mean, at least this part is quite easy to change. I'm very happy, like in the beginning, I had it in a way that you really had to take those out in order to get the bearings, which was not fun. So let's just remove both of them. Let's just try one. So in the beginning, I had issues with these when I tried to move it manually. But partially, maybe I think the problem was that I moved it manually because I didn't apply equal pressure on both sides. So maybe these are the better choice after all. And the other problem with these is they need a specific pressure, which I can't really guarantee. So basically they only work properly if they have a very specified pressure applied from the outside. Okay. Let's do a slow test run. So far it works. Let's speed up a bit. That was way better. Oh, wrong direction. Also a bit, but way better. This one is way better. Now the question is what happens if we add a second one? Sewing machine oil will be better and work also on IGUS. Oh, really? You can use sewing machine oil on IGUS? Because I read a bit into IGUS in the beginning, and I basically read that they're self-lubricating and you should not add any external lube, because they will just like collect the dust, because they will like wear out, right? They will wear out over time, like slowly. And if you add any like lubricant to that externally, like basically the lubricant will cause the dust to collect and accelerate the wear. Not quite sure if that's accurate, but that's what I read. But I'm not an expert. But to be honest, like if we have this problem for now, I think I would be okay with that. Like if you have this like resonance issue, because I think that's something we can save later, potentially with better parts. Because like these are AliExpress bearings, so yeah. See, now it's like already really hard to move. Yeah, so you really cannot tighten this a lot. That's a bit of a problem. Because then you will have like a lot of play. And I don't want a lot of play in my tool head. Okay, let's see. Let's do again the slow test run. That was like with 10,000 was now super fine. With 20,000 you have it again. But these are way better. That's one thing that's for sure. Like it's way quieter. I mean, that's kind of the point. I like the color scheme. Thank you. I also like the color scheme. I just don't like the material is a little bit iffy to print sometimes. But yeah. Like I kind of like the teal. I might look for a different teal color. This is the Polymaker ABS, and I like it's generally it's okay. I struggle a bit with overhangs, but it could just be like my print settings. And I use a lot of overhang prints on this machine. Okay, I'm just checking if. So I wonder, because like that's one thing I kind of forgot to check actually, or like to test. The belt almost touches the side of that. Like it doesn't quite, but I'm not guaranteed it won't. So I wonder if this is part of the problem. And the other funny thing is, right? So we only have this problem if we move in one direction. Let's actually quickly do the speed test macro again. So let's do just a speed test with 1000 acceleration. But yeah, it's much quieter. So basically, we only had the problem if both motors work at the same time. So it's only like if only Y moves or only X. No, sorry. If only one motor moves, everything is fine. Only if both motors move together, we have a problem. So this was 1000. Let's quickly do the 4000 again. I have Polymaker Teal, will combine it with black. This is Polymaker Teal and I combined it with black. That's exactly the color scheme. And it's Polymaker ABS Teal. The black one is Form Futura Titan X. But yeah, black is black. But yeah, it's a really cool color scheme. You chose wisely, I think. Cool, so I'm not quite sure what to do with this. So if both motors work, I have vibrations. And it's really funny because I have the exact same issue on the switch wire. I mean, we can do a Google search, right? Core XY resonance vibrations if both motors work. So basically, if the printer moves in X or in Y, like if it does diagonals, it's fine. But if it does like X or Y, there's like a lot of like I would describe it as resonance vibration. You know, like when the printer hits like this like resonance frequency and like gets like really loud. So technically it's fine, I guess. Wait, wrong printer. But actually let's quickly try like a higher acceleration, just out of curiosity. It's like 6000. Just holding it. This is quite light. Technically, it can move quite well. So there was the main problem I wanted to solve today, right? That we had like these like sticky spots, and it's all gone, so that's fine. And for this problem, like I'm not quite sure if it's really a problem we need to fix now. I don't know. Very loud when moving fast. I have no clue what to Google there. I think this is the same issue. Not quite sure if you can hear sound actually. This is happening because the torque of the motor. So the motor has too much torque, you're saying? And because the belts are not equally tensioned. I'm pretty sure the belts are kind of okay. Let's consult our like fancy pants. So that's 2.5. It's also 2.5. The tension is equal, like it's also docking like nicely on both sides. So that should be fine. So belt tension should be equal. I can show the printer config for sure. I can show the printer config. Printer config. So basically we just took the standard config of the SKR Mini E3 V2 for an Ender machine. And then we just modded it. So I mean, it's also stealth chop is on. And we can reduce the run current. That would reduce the torque, right? I had this problem when the tension wasn't right. I mean, we also tried to loosen the tension a lot and still had the same issue. The interesting part would be, will we get this issue if nothing moves? Most likely not. I mean, the tension is relatively high right now, so let's just do the fun part and just let's reduce the tension. Now it's really low tension. Like, this is not feasible, but just for a test. So if we do the same thing again, maybe acceleration a bit lower. Yeah, it's still doing it. Now tension is like super low. So I don't think it's a belt tension. We only we noticed that with higher tension it gets like noisier, but I think that's just kind of logical because like the tension just like transfers the vibration better, I guess. Let's actually do this to the front. Okay, now the tension is perfectly equal now because like it's like it should be because it's like docking here. It's like kind of okay, I guess. Like it's not super tensioned. You can paste the link here in chat. So it's totally fine. If YouTube allows that I don't know. They are aligned in the front, so given that this is square, which I wouldn't guarantee, it should be fine. But I'm curious, maybe we can also swap out, I mean, that's not super important right now, but I was also try to like swap out the Y bearings for these, because like these seem to work quite well now here. Like you cannot tighten it a lot, which is fine, I guess. Like you need to tighten it the right amount. Let's see. It's also something I might just ask in, I don't know, like the Forum Discord or something. This to the config. Yes. But I don't have input shaper, right? I don't have input shaper because like there's nothing here. So I'm not quite sure if it will eat that. Doesn't matter, okay. I'm pasting. Okay. I just pasted it. It is added. It accepted it. Let's just run the acceleration then again. Still doing it. Still doing it. I'm not sure if it's a bit better, maybe. But just to confirm, so basically I just added this now with the lines commented out, right? So it's just the dampening ratio. You think it's better? What does this do? Dampening ratios of vibrations of X and Y axis used by input shapers to improve vibration suppression. Default value 0.1, which is good all-around value for most printers. In most circumstances, parameter requires no tuning. What do we have? Let's just try 0.1 default value. Let's just try this again. Yep. I mean, not sure if it does something, to be honest. I feel like the horizontal ones are even better, but it's better than nothing. But I would like to understand the general problem, like where it comes from. Because like for me, like I have the same on the switch wire. I have the same problem there. So it would be really interesting to understand where this comes from. Remove the comments. So you really want me to enable input shaper? Oh, that was not what I wanted. Okay, so now we have input shaping enabled. Okay, so here's the thing. In X is quite good actually, right? X is fine, but Y is still like very noisy. So I think that is where maybe the linear bearings would come in handy to remove that in X and Y, because like X is now way better. Like if I just do the what we had before, this one. Okay, that was also like quite noisy. $10,000 is super fine. 15,000 is horrible. Can I see the TMC in the config? Yes, you can see the TMC. Printer config. So that's the TMC. Like these two are the 0.58 amps is the standard that comes from the Creality config. You can have it big. No, you have it bigger. I hope it's big enough. We can also try what happens if we disable stealth chop. Oh, sorry. I don't show it. Sorry. My bad. Stealth chop to 0. I always put it to 1. Because then if it's holding, it's still in stealth drop. But we can put it to 0. Let's put it to 0. Okay. Let's try again. Microstepping to 64. Okay, let's quickly do one test run and then we do the microstepping. Ha! It's gone. It's gone. So it's a stealth chop. Let's stealth chop. Ha! I didn't know. But I still wanted to have it at 1. Because now you hear the motors like holding. So when the printer is still, it's not fully quiet. So I put it always to 1. So as soon as they move, stealth chop is off. But when they hold, it's on. I had the problem with my V0 that the motors were super whiny when they were like off. Like not off, but like holding. It was like super annoying actually, because even the printer not doing anything, it was like, it's like super annoying, like high pitch sound. Like I hate it. That's why 1. Okay, and then the microsteps you said 64. Let's try 64. Interpolate faults. Okay, step by step. Let's try microsteps. I'm not sure if it's much better, but it's like the stealth chop really did it. Interpolate faults. Okay, let's try interpolate faults. You spill like a lot of like secret knowledge here. Yes, I'm very happy now. What makes me happy is not that this motor, this printer is now fixed, but what I can now try tomorrow with my Ender. So now you hear Y is louder, but not from vibration, but you hear the ball bearing. You really hear the ball bearing. So I think I will really like, not gonna do it now because like we have to disassemble at least. Yeah, we have to take those apart and that's kind of like a shit show. So I'll do that tomorrow maybe. But it works quite well. Let's just try a little bit higher. What can I do? So let's just go up to 8. deactivate the input shaping. Okay, let's see quickly. That can move quite fast. Input shaping, and you will see that also input shaping helps even that the values are not correct yet. Okay, we can just disable that. So let's just kick this all out. Input shaping is gone. To be honest, that doesn't make a big difference for me. Like I don't really hear like a lot of difference there. I went 3K more Excel on my printer. Like the acceleration definitely will go up. But to be honest, I feel like the max speed is at the moment also a bit a problem. I don't think it's getting like tons of faster. So that's just. I just set the speed now to 999. Let's see. Maybe now it explodes. Okay, so now we found the limit. Now we found the limit. But it's really stiff in X to move. Much better. So you really cannot like tighten this a lot with the IBOS bushings. In small distance acceleration is important. Yeah, exactly. But I think now the problem was that the max speed in the printer config, I need to check what is set there, but I think it was quite low. Max velocity is 300, so I think like because the acceleration was like at 8,000, it reached the maximum velocity quite quickly, and that was capping it out. Now that I basically removed that maximum velocity like cap, now basically it started skipping steps because it couldn't hold the velocity. But I mean, like, this doesn't need to be like a hyper fast printer, right? So that's totally fine. Don't move it. I have to constantly remind myself. But basically, goal for the day achieved. Now the question is whether I go with the metal bearings or with the IGOS bushings, fake IGOS bushings. So the y-axis is definitely louder, that's for sure. But I don't feel super confident because like you see like how like flimsy this now is. Like it's like really wobbly. I just left for a bit, sounds so much better. Yeah, Nadir is a wizard when it comes to stepper configuration. It's just software. I use IGOS. Please don't use a stealth job threshold of 1, either 0 or 999,000. Why not 1? What's the problem with 1? I use 1 on all my printers. I've heard it's quite discouraged to use anything other than those two numbers for the stealth job threshold. Yes, it is, I think. So basically 1 just means if the printer is standing, it's stealth job, and if it's moving, it's not. I think like what is discouraged is to set it to like, I don't know, like 1,000 or something, because then while the printer is moving, it switches between stealth job and spread cycle. That's the word. But I think 1 is fine. I don't know, like I don't have any problems with that. The only thing what I will do now is, because on my ender wire I run stealth chop on X because it's like super noisy without, but I will try like Nadir's special configuration tips and see if I can get rid of the stealth chop there. Yeah, and the switching is not good. Yeah, but the thing is, like, your printer doesn't stop during print usually, right? So I don't think that the 1 is a big problem. Like, at least I don't have any problems. So I use it since quite a while, actually. Team C29 can go until 250 microsteps. But the microsteps are also dependent on the stepper. No, like the stepper doesn't matter, right? It's just the stepper driver that has to be able to do the microsteps. Cool, but yeah, but yeah, also more microsteps is less torque, if I remember correctly, right? Like the more microsteps you add, the less torque you will have. When you increase the microsteps, you lose torque accuracy. Yeah, okay, exactly. But stealth chop 0 adds torque. Yeah. Yeah. The funny thing is, like on my switch wire. So on Y I run spread cycle, so I have the stealth chop at 1, and on X I run stealth chop because it was so incredibly noisy with spread cycle that I just turned to stealth chop. But I will definitely try the microsteps and stuff. I will try the microstepping with like 64-128. And then potentially this helps the noise, and then I'm happy to like turn off the stealth chop. And then maybe like this like very loud movement in X that I have, it's the exact same that we just solved here. Maybe then it's also gone. That would be really amazing. Oh, disable hold current. I can also try that. That's also interesting. Cool. Yeah, but I think I would wrap it up then. That is like mission accomplished. I think perfectly. Like it works very nice. Like I did not expect it to like perform this nicely, because it's just like some random ass rods and a little bit of plastic, and it's like, it's not super wobbly now, but it's not the most sturdy thing on planet Earth. Input shaper results will be funny. So just like to wrap up. So my plan at the moment. So initially I wanted to use this tool head here, right? Like this is the mini stealth burner in the Bowden configuration. So this was my idea initially, because I wanted to use like very cheap parts, and I didn't direct drive at a cost and whatnot. But like recently I kind of went on an AliExpress shopping spree, and I kind of bought a couple of things. And I bought stuff for the V0. So the V0 we will convert to CAN bus at some point. But I'm also almost certain that, so this machine will get direct drive. So I already have the stepper driver here. And my current idea is to use the toolhead board of the V0 and transfer the toolhead board to this machine, so that we have like a nice toolhead board there. And that toolhead board has an accelerometer. So technically there would be, we can do input shaping and everything. So that would be nice. But I'm also thinking, because the, wait, where is it? Somewhere in my mess. Okay, no, maybe not in my mess. Okay, so somewhere like the, I forgot the name, like there's this toolhead board from Big Tree Tech, and it's like super cheap. It's like a canvas toolhead board, it's like 16 euros. And then there are like these like super cheap adapters. So if I spend like another 20 euros, we can just like throw canvas on here. So I'm kind of like inclined of just doing that. Like if this, let's just say like the motion system works nice. I'm super happy of like spending a little bit more money on this machine, make it like a nice machine. Then something else I will do, depending when the weather is nice, because I have to bike there. I will go to the hardware store and buy more of the, so I have like 3 different types of rods here at the moment. Yeah, I have the hollow ones, which are quite shit, and then I have the solid ones, which are way better. And for example, the front one here is hollow, and the bottom ones here and here are hollow. So these I will replace with the solid variety. And then like the chrome one here are proper smooth rods. So they're like steel, basically. EVB 36, yeah, EVB 36, not 2209. EVB 36 was the one I forgot. I have one here already somewhere. Like I have no clue where I put that, to be honest. But yeah, I have one EVB 36 that will go into the V0. So at some point, how I will do this with this machine, because like it takes a lot of time for me to work on this, because it's, yeah, I have to design the parts and I don't have like tons of free time at the moment. So I can't like spend a day of sitting in front of a CAD program and designing parts. So it's a slow progress. But I'm committed on finishing this. Like I will not stop, but it's a bit slow. So I think what we will do is like we will always do like projects in between. So I try next week that we like have the bottom part somewhat ready, that we can add all the things without the skirt, just like the bare bone parts basically. And then after that, I will have to go back to the drawing board and I have to design the bed mount, basically. Let me quickly... EB36, the aluminum rods are 8mm. This is the reason your bearing are playing. No, the bearings are on smooth rods. These are good rods. Only the ones without bearings are aluminum rods. And these are actually too thick. They are like 8.1, 8.15. So the bearings don't even fit on here. I tried that. There was the initial idea was to not use proper rods, but yeah, the rods that are like with the bearings, so these and the verticals, they are like metal smooth rods. Okay. So this is the current CAD situation. So I basically have the corner pieces designed. Spartacus, the tool head. Okay, let me quickly finish here and then we can check it out. So basically, this is the current status. And what I want to prepare for next time is basically that we get it up to this level. This would be like my goal for next time. I just have to print all the parts. I'm not quite sure if I will get there. I'm home on Sunday, so I can print quite a lot, and I'm home next Friday, so I can also print some stuff. But basically this would mean we can install the 2 steppers for that. That also means we then need to use the proper main board, which God knows where I put that. Okay, somewhere I have a box with main boards and toolhead boards. Yes, that is belt, 4 belts. We have 4 belts. So we have basically, here's the top idler of 1 belt. Let me just try to... So this is 1 idler for 1 belt, and this is the other idler for the belt, and then on both sides. And then on the bottom, how this works basically is the motor is like geared to the 50-tooth gear. And then you have 2 pulleys here, and the 1 pulley will go to the front. Like the outer pulley goes to the front, and then you see like there's like two bearing stacks here that route both belts to the top, and the hind pulley that just goes straight up. And then basically the trick is that on the bed, basically you attach it on all 4 corners to the belts, and then on basically you have like 4 belts going up per side, right? Like one belt goes up and like comes down. So you always have to grab the opposite side. So the 2 inner ones, I'm not sure how to explain it, but yeah, like basically you attach it to the opposite sides of the belt because like from all 4 belt loops, one side always goes up. That's what I'm trying to say, very complicated. So yeah, so that will be fun. And this way we can have 4 belts and we only have 2 motors. And all the main boards, they have the dual Z plug anyway. So where you can put 2 motors on one stepper. So that should work with any main board. We can make the fun if we have a canvas toolhead board in the end. We have 1 free stepper. So we can also drive those 2 motors individually. Although I'm not quite sure what we would gain from that. Maybe like more strength for like lifting heavier beds, but yeah, technically not needed. So yeah, so that's the idea. And these are just like relatively big parts, so I have to print them worst case 1 by 1, so it just like takes a second. But yeah, that's what I have planned so far. And then yeah, next step would be like the bed. And then after the bed, the electronics. Oh, I didn't show them. The electronics will be underneath. So this is the power supply we used already today. So I have that. Raspberry is a Raspberry. And then on the back, I kind of have the idea to have like this vertical structure going up so that there's like a backpack basically. Not sure how to describe it. Basically backpack with the mainboard inside, so the steppers have quite short wire runs, and like this is kind of like the best place for me to have it because like the wire loom comes from the top, the bottom steppers are quite close, so this is quite a cool spot to put this, I think. So that's kind of like the plan. Oh yeah, and here for the skirts, I'm not quite sure if this is the final design. I think it's quite cool. So the blue, the teal part would be mesh, of course. And yeah, I have SKR Pico as planned. The SKR Pico is exactly what I have planned for this. I have one over there, just for this printer. It's not only a small footprint and powerful, it's also super cheap. Like I got it for 25 euros or $25 basically in some AliExpress sale. I just bought 2. So yeah, and the white part here, so the blue part is mesh and the white part is this LED strip. So the white part will be LED. And I hope this will look quite cool. And it's just a bit of a pain for the skirts because like you still have the 2 rods that you kind of have to like work around. I think the side skirts might be simpler than the front skirts. Maybe just like a cover. Nothing too fancy. The thing I didn't solve yet is where to put the power plug. That's a bit of a conundrum I still have to solve. I have 20 printers. I don't have 20 printers. If this is ready or like if this is working, it's number 3. And I do have plans next year to get 2.4, 300 or 350 even. Let's just say if I had 20 printers, I would need to put them on my bed. Otherwise, I wouldn't have enough space for 20 printers. Cool. Yeah, but then let's wrap it up. Thank you everyone for joining. Thank you Nadir for all your amazing stepper driver knowledge. And yeah, I tried to print it. I'm really like excited now that it moves. Like it moves way better than I expected. So suddenly this really seems like a feasible project to finish. And yeah, thank you everyone for tuning in. Enjoy your weekend. And yeah, see you next time. Bye, Paul. Bye, Steve. Bye, everyone.